Hello everyone, welcome to Gate Wallah. So guys, I hope you all are watching Gate Aerospace lectures, and in the lecture series of propulsion for the aircraft system. Uh, I had asked you, many of the students, on which all topics you want me to teach you. So guys, I got a response from many of you that you want something related to propulsion efficiency, engine performance. So guys, in that line only, today we are going to start with engine performance. But to discuss engine performance, first we need to understand very important principle of generation of thrust. So all the aircrafts or vehicles, space vehicles which you see, they work on Newton's laws. So today we are going to discuss about how the thrust is generated and what are the different components of thrust. So I'm sure you guys might be watching these lectures, and guys, Gatewala has started aerospace engineering preparation as well. So those of you who are going to appear for Gate Aerospace 26 or 27 and future, guys, you can join the batches for aerospace. They are already in the progress. One subject has already been completed, and there are lectures which are going to be scheduled for other subjects also, which have been already scheduled, and to get a glimpse of how the teachers or faculties are teaching you. So guys, we have brought this series on YouTube to help you understand on what is the quality of content that you are going to get. So I am myself Vinod Kumar Datusliya. I am All India rank 1 in GATE in mechanical. I have done my MTech in aerospace engineering from ISC Bangalore. I have designed aircraft. I have worked in many companies. I have designed aircraft engines. I have worked for GE General Electric, which is one of the pioneer companies in terms of aerospace vehicles like aircraft engines and other a lot of fighter jets which are designed for throughout the world are mostly designed by GE. Okay, so in this series we are going to start with propulsion videos, and I have already taught you two lectures, one on the nozzle and other on the gas turbines. Today is the third lecture, and today we are going to discuss how the thrust in aircrafts or vehicles is generated. But to understand the concept of thrust, I'm sure you guys have to understand what are the Newton's laws. Okay, so we are going to derive the thrust equation, but before that, first let's help understand what are the Newton's laws. So specifically, the thrust equation is related to Newton's second law and Newton's third law. Okay, but let's begin with Newton's law. So first, I'll give a glimpse of Newton's first law. Then we will go to Newton's second law and third law. So if we talk about Newton's first law, so you all might have you all might have studied in your 11th class, or before that maybe recently it has come to 8th, 9th class as well in the CBSE syllabus. So Newton's first law. What does Newton's first law say? Newton's first law says if a body is at rest, if a body is at rest, it will continue to remain at rest. So let's say this is a body. When we say it is at rest, that means there is no change in position of the body. With respect to time, it is staying over here. So let's say at t is equal to 0, at time t is equal to 0, it is lying at this position only. You came back after maybe 5 minutes and you saw that at time t is equal to, let's say, 5 minutes, you saw that this body is again lying at lying at the same position. Okay, so this is what we say rest. When a body is lying at one position, it will continue to lie at its position, same position with respect to time. So this is what is called as the condition of rest. Or if a body is moving at constant velocity, so let's say if a body is moving, it is moving in this direction with a velocity, let's say velocity I have 5 meter per second. So this body is moving with velocity 5 meters per second. Newton's first law says, if a body is at rest, it will continue to remain at rest. If a body is at rest, it will continue to remain at rest. Or if a body is moving, it will continue to move with the same velocity. So again, velocity is 5 meter per second. If a body is moving, it will continue to move with the same velocity. That means at time t equal to 0, it was over here. At time t equal to 5 minutes, it is over here. Okay? So Newton's law is related to these two positions or these two conditions. If a body is at rest, it will continue to remain at rest. Or if a body is in motion, it will continue to move with constant velocity until and unless acted by an external force. That is what is the Newton's first law. So if a body is at rest, it will remain at rest. If it is moving with velocity, it will continue to move with the same velocity until and unless it is acted by an external force. So Newton introduced the first term that is called as force. He said that there will be something which will be acting on this body which can change the state of the object. This state is rest. This state is it is moving with a constant velocity. So they will continue to be doing their function until and unless they are acted by a force. Now, what happens when the force act? When the force act, this body which is at rest might continue to move or might start moving. This object which is moving with a constant velocity, it can change its velocity, it can change its direction, it can change its state. Like it will stop somewhere. It can move faster. It can move in other direction. It can move in this direction. It can move in reverse direction. So the state of the object will change, or the position of the object will change if there is a force acting on the body. Okay, so this is what is the Newton's first law. Now to help you identify what does Newton's first law says, let's say this is an object which is lying on my palm over here. If I don't move my palm or if I don't apply any force, it will continue to remain over here with respect to time. But to move it, I have to apply a force. So I have to push it. I have to push it or either pull it. Okay? So the force is nothing but a push or pull on a body. So if I have to push it, that means I am applying a force. If I am pulling it, that also means I am applying a force. So until and unless I apply a force on this body, its state or its position is not going to change. So that is what Newton in principle said. Okay, this you might have observed. Newton's laws you might have observed at multiple locations. You might have seen it, that Newton's first law, let's say you have a room. In this room you have, this is what is, let's say your room is there. In this room there is an almirah over here, and on that almirah you have kept something. Now you see that this object which is lying on the almirah can continue to remain in this state for months or years. In every home there is always an almirah on which there is something lying, on which dust has accumulated a lot, and every Diwali this dust gets cleaned, but the object lies there only. So that is in principle is what Newton's law, Newton's first law. Object is lying at rest, it will continue to remain at rest. Okay, so this is the first thing that you might have observed. Then second thing is you might have seen a lot of space movies, or you might have seen some of the movies where people or the constellation or the solar system are shown, where you see that an object is moving like this and it is constantly moving in a straight path. It is constantly moving in a straight path. You see, this is our Earth, and when any object which goes out of the influence of the Earth, let's say we have sent an aircraft which is like over here, Voyager, you might have heard, it has recently crossed Pluto. Okay? So Voyager is moving like this. So it will continue to move. It has been moving for last 50 years with constant velocity. Okay, Newton's first law, classic example. Okay, so in the space, everything will continue to move until and unless some other planet applies a force. They influence that object by application of force or by gravity. Okay, so that is the first law. Now, Newton said that an object will continue to move or it will continue to lie at rest until and unless acted by a force. So he has introduced one term that is called as force. To quantify that force, how much that force is. So to quantify, Newton has given the second law. He said, in continuation, he said, and the force would be proportional to, this is what is the exact word he said, and the force would be proportional to rate of change of linear momentum of the body. Okay, so he has introduced a term force in the Newton's first law. He has introduced a second term in second law. What is the second term? Second term is the linear momentum. So he has introduced linear momentum term. Okay, so when he said force will be directly proportional to rate of change of linear momentum. Now, what is linear momentum? When we talk about linear momentum, he defined linear momentum of a body. Linear momentum of a body is equal to mass multiplied by velocity of the body. Okay. So mass multiplied by velocity. So let's say I have an object which is over here. It has a certain mass of m and it is moving with a velocity v. Then the momentum, which is generally defined by p, is called as m dot v. Okay. Mass times velocity. Momentum. Velocity is a vector quantity. So momentum will also be a vector quantity. Both of these are vector quantities. Force will also be a vector quantity. Force is also a vector quantity. It has a magnitude and it has a direction. Even if the magnitude remains same but the direction changes, the value of force changes. Okay. So linear momentum is nothing but m into v. So now if we see what is the force, so you see force will be directly proportional to rate of change. Rate of change is defined as d by dt of mv. So this is what is the Newton's second law. Exactly this is what is Newton's second law. But most of the people, they don't understand this law, and people simply say F is directly proportional to d by dt of mv, and they write F is directly proportional to d by dt of mv if the body is there, if the mass remains constant. Okay, so generally people say mass remain constant. So they take the m out and they write d by dt of velocity. And d by dt of velocity is nothing but acceleration. And people write force is equal to mass into acceleration. This is second law. Actually, this is wrong definition. It is never correct definition. Most of the people, those who do this is wrong actually. The actual definition of force is, if we differentiate this, okay, so if we differentiate this, then there will be two terms. One is if the mass remains constant, then it will become m into dv by dt, plus if the velocity remains constant, then this becomes dm by dt. So these are the two terms which are actually present in the Newton's second law. Okay, so first term is force is directly proportional to mass times acceleration, which is called as the linear acceleration of the body, plus velocity times dm by dt. And you see this term becomes very important in case of rockets. This is what is responsible for rocket thrust. ठीक है, thrust which is applied on the rockets. Rockets are the space object, or they are the vehicles in which mass is ejected out. Mass is ejected out with certain velocity. So that rate of change of mass is what gives you the force. Okay, so there are going to be two terms in the force. First term is mass multiplied by acceleration when the mass remains constant, but there is a change in velocity, and other is velocity remains constant and mass is getting rid of. Is it clear? So this is what is Newton's second law. So now we have seen what is the value of force. So this thing we have seen. Now comes the Newton's third law, because in every vehicle that we are going to see, these both laws are going to be used together. It is never going to be alone. It is never going to be same law. All the vehicles that you see, all the aircrafts that you see, all the rockets that you see, then the generation of thrust uses both the law, Newton's second law and Newton's third law. So Newton said this force is acting on the body, and he has measured the force. Force will be equal to rate of change of linear momentum, which is ma plus v dm by dt. And he said this force which is applied on the body. So let's say you have this body. On this body, there was a force applied. Okay, there was a force applied on this body. Okay, so when this force is applied on the body, the force is applied by some other body. This is body number one. If some force is applied on this body, it is applied by second body also. So there are going to be two bodies in this action. One on which force is applied, other which has applied the force. So when Newton calculated everything, he saw one more thing, which he gave as the Newton's third law. He said, if there is an object on which a force is applied, let's say this is object number one. On this object, there is a force that is applied by another object. So there is a force which is applied by white object. So this is object number two, or this is, I can write, this is pink object. This is pink. I will denote it by P, and this is white. Okay? So there is a force that is applied by white on pink. So the force applied by white on pink is going to accelerate this object. When there is a force applied in this direction, there will be change in momentum in this direction. So velocity will increase and this object will accelerate in that direction. So Newton said, when there is a force applied on this object by this white object, the same force will also be applied on the pink object on the white object by the pink. The force which is applied by white on pink, the pink object will also apply a force which is equal and opposite. So the force applied by white on pink, the pink will also apply a force on white. And that value of that force will be equal and opposite. Equal and opposite means equal in magnitude, opposite in direction. And this is what people say, every action has equal and opposite reaction. This is what people most commonly say. So every action has equal and opposite reaction. That means if there is a force applied by white on pink, this is the action. White applies a force on the pink, that is the action. So every action will have an equal and opposite reaction. So when there is an action applied on the pink, there will be reaction by the pink on white, and that is equal and opposite. I hope everybody has understood this. So all the three laws, Newton's three law, I hope you might have understood. We are going to see in detail how this Newton's third law, every action equal and opposite reaction, works. We are going to see how the Newton's second law, which is the calculation of force, is going to be applied on the aircraft. Is it clear? So I hope till now Newton's all the three laws are clear to everyone. So now we are going to see how thrust is generated in aircraft. Okay, so thrust in aircrafts. Okay, so to understand the thrust in aircraft, first we are going to see naturally aspirated aircraft. That means aircraft which takes in air, do the combustion or release some energy into the air, and then they make use of the air which is present in atmosphere. So let's say we have an aircraft. So I'll just draw an aircraft, simple aircraft. So this is an aircraft. This aircraft which is moving through the atmosphere. Okay. So in while it is moving through the atmosphere, you see that there are wings, and on those wings there are generally two wings which are there on the aircraft, and on those two wings you see two engines. So let's say we have an engine over here. We have an engine which is mounted on this aircraft. Okay, so this is one engine, and you have another engine which is mounted over here. Okay, so these engines would be below the wings, but I hope you understand that these are the wings. So to make you understand this is below the wings, I can draw it with the dotted line. Okay, so that it looks like there are two engines. Okay, so now you see that what or how does the aircraft actually moves. So what happens is these engines take in air at certain velocity. They suck in air at certain velocity. Okay, if I tell you what happens in an engine, so to give you an idea of what happens in an engine, let's understand over here. So let's say this is your engine. Okay, and in this engine there is generally this is how the engines actually look like from outside, though inside what happens that is slightly complex, but I'll give you a brief on how does this engine work. So let's say these engines suck in air from here. They suck in air at certain mass flow rate, which is mass flow rate of air. Okay, they suck in it with certain velocity, which is generally called as v infinity. Okay, now what happens is when this air is coming with certain velocity, over here what they have is they have certain fuel supply. So they inject fuel, and the fuel is injected at a rate of, let's say, m dot f, mass flow rate of fuel. When that fuel is entered, that fuel is burnt. When that fuel burns, it releases energy, and when it releases energy, it releases heat which goes inside the air, and it increases the temperature and pressure of the air. Once the temperature and pressure of the air is increased, so now you see you have a nozzle over here. So we have already seen in the first class, which is the nozzle, we have seen that these gases which are coming out of air, they are accelerated. So when they are moving out, they have a high velocity. So they are moving with a velocity which is, let's say, v exit. Okay, and the mass that is coming out is mass flow rate of air plus mass flow rate of fuel. Okay, so this is what happens. So now you see when the air is coming in with a velocity v infinity, and you see when it is going out is with velocity ve, and we see that ve is generally much greater than v infinity. So if there is an increase in velocity of the air, so you see when the air was entering over here and air is exiting over here, if you want to see what is the change in momentum of the air, you see that this was moving with the momentum m dot a into v infinity. And when it is going out, it is having a larger momentum, which is m dot a plus m dot f into v exit. So you see that there is an increase in velocity and increase in momentum. That momentum has increased in which direction? So you see on the air. If you see on the air, so let's say this is my quantity of air. So you see when it was coming in, it is having a lesser momentum. It is going out, it is having a higher momentum. So can we see there is a force applied on this air? There must be a force applied on the air, because of which the momentum of the air has increased, or momentum of the air has changed. So now, which is the direction in which the force has been applied? So you see that momentum has increased in this direction. Momentum has changed in this direction. That means force is applied in this direction only. Okay. So there is a force applied on the air. Now tell me, who is applying this force? If you see the force applied on the air, so air over here was all alone. Air over here is all alone. While it is passing through this is passing through a device or an engine. Okay? So that means when the air has accelerated, the force must have been applied by engine. So this is the force which is applied on air by engine. On air by engine. So can I say the same air would also apply a force on the engine? This air would also apply a force on engine. So let's say this is your engine. I write this simply like this. This is your engine. So can I say there is a force that has also been applied on the engine by air? So there is a force applied on engine by air. And when there is a force applied on this engine, that means there is a force which is applied on this engine, there is a force that is applied on this engine. So both the engines are getting some force, and that force is getting applied in this direction. It is getting applied in this direction. Okay. And because of this force, you see the engine moves ahead, and engine is mounted on a wing. So wing move ahead, and wing is attached to the nacelle. So this all move. So the aircraft actually moves in the forward direction because there is a force that we actually called as thrust. There is a thrust which is applied on aircraft, and because of that thrust, the aircraft is moving ahead. So you see, there are two laws which have been applied. The Newton's first law, which says the force, Newton's second law, that says the force is applied, and the magnitude of force is, we are going to soon calculate. And Newton's third law, which says that if there is a force applied on air, air would also apply a force which will make the aircraft move ahead. Okay, so this is what actually the thrust looks like. Is it clear? So I'm sure everybody might have understood how the thrust is generated in an aircraft. So we are going to see how the thrust is actually generated. But this is only the one component of thrust. There are other components of thrust also. Okay, so I hope all of you have understood how the aircraft actually moves. So if you have understood, then let's go ahead and let's calculate, or let's see what are the different thrust components which are actually applied on an aircraft. Okay, so this first thrust component that we are going to see is because of change in momentum. So what I will do is first we will first, just hold on a second. I will copy this slide. Okay. Okay. So now we are going to see how, what are the different components of thrust. So first I am going to rub this aircraft because we don't require it over here. And this also I am going to rub it. So the first thing that we are going to see is aircraft thrust due to change in momentum of the air. Okay. So this is the first component of aircraft thrust. So I'll put it over here. So thrust due to change in momentum, of air. So first we are going to see this component. Okay, so if we are going to see the first component, so let's say there is a air which is coming in. So first we will write that air with velocity v infinity enters engine at mass flow rate, that is m dot a kg per second. At mass flow rate m dot a kg per second. This is air entering. Now we burn a fuel with mass flow rate m dot f is supplied to air. ठीक है, is supplied to air, and this fuel which burns, it releases energy, and that energy is consumed to increase the velocity of air. So finally air with mass flow rate m dot f plus m dot a exits with velocity ve. Is it clear? So it exits with velocity ve. Now we have to calculate how much is the thrust, how much is the force that is exerted. Okay, so to understand this, we are going to again write the Newton's second law. So Newton's second law says force is directly proportional to rate of change of linear momentum of the body. So here we are going to see what are the linear momentums which are getting changed. Okay, so to understand this, let's say first discuss the proportionality constant. So if we are going to use SI unit, that is standard international unit, so in SI system, okay, in SI system of units, the proportionality constant which can be written as force is equal to K into d mv by dt. Okay, so proportionality constant in SI system is 1. K is taken as 1. This is the standard that we have fixed. In case of MKS system or FPS system, the value of K is different, because there the value of force will change accordingly. But in SI system, Newton, which is 1 Newton, is adjusted in such a way that it will this K will come out to be 1. Okay, so in case of SI system, you can write force will be directly proportional to rate of change of linear momentum of the body. So now here we are going to see we have two objects over here. Okay, one is the air and other is the fuel. So both of these we are going to see what is the change in linear momentum. So but before that, to understand what is the change in linear momentum, this can be written as d by dt of mv, rate of change of linear momentum. ठीक है, so this can be written as final linear momentum minus initial linear momentum. Okay, and since we have a dt over here also, so d of mv is final linear momentum minus initial linear momentum. We have dt also. ठीक है, so this becomes rate of final linear momentum. Either you can write it like this, or you can write rate of final linear momentum and then rate of initial linear momentum. Okay, so now to understand what these two parameters are actually looking, we are going to see a lump of mass. Okay, we are going to see certain mass. Okay, so if you see over here, let's say you have a certain mass, then you have final linear momentum is v exit or v final, ठीक है, minus m v initial. Okay, and then you have by dt. So if there is only a certain portion of mass, if there is a fixed quantity of mass, then this dt would be the time for which the force is applied. But in case of a constant moving system, in case of objects where there is a continuous supply of mass, so this dt is actually clubbed with mass or this mass, and it is written as m dot, rate of change of mass, which is continuously. M dot is actually the mass of air which is coming in continuously. So this becomes m dot into v final minus m dot into v initial. Okay, so this becomes your force. So the force applied on an object is m dot v final minus m dot v initial. So this becomes your final linear momentum. This becomes your initial linear momentum. Is it clear to everyone? So let's say when there is an aircraft which is, or there is an aircraft engine which is lying over here. So we have already seen this case. So now I will draw this picture once again over here. So in this case, let's say we have an engine over here. Okay, and when the engine is sitting over here, let's say there is an engine which is lying over here. This engine is at rest. This engine is at rest. That means the velocity of the engine is 0. Velocity of the fuel which is coming in is also 0. Okay, then you have mass of air which is coming in with velocity v infinity. Mass of air which is going out is ve. So can I see what is the force applied on, what is the force applied on air? So what is the force applied on air? Can I say final momentum of the air which is going out minus initial momentum of the air which is coming in? Okay, or you can write force applied on air plus fuel. Both of these are moving together. So what is the force applied on air plus fuel? That will be equal to, so force applied on air will be the final momentum minus initial momentum. Is it clear? So what is final momentum? If everybody see that final momentum will be equal to mass flow rate of air plus mass flow rate of fuel multiplied by v exit. This is the mass. This is the momentum, final momentum, m dot f plus m dot a into ve. Then minus initial momentum. Initial momentum will be mass flow rate of air multiplied by v infinity. This is the momentum of air. Now what is the momentum of fuel? So this fuel is resting stationary. This engine is stationary and the fuel is being supplied from the engine. So if the fuel is being supplied from the engine, this will become mass flow rate of fuel multiplied by 0 velocity. It does not have any velocity. So you guys might be having a doubt in your mind that, sir, when the aircraft is moving, at that time aircraft is having certain velocity. So this engine has certain velocity. So how you are saying that this engine is at rest? So guys, this example will be discussed later. I will discuss it later, but it does not matter, because in that case, the air is stationary and your aircraft is moving with the velocity in this direction. Okay, so to understand it, so first leave it over here. I'll just show you. So air is sitting with v infinity is 0 and your engine is moving in this direction. Okay, and when this air enters engine and when it exits out with v infinity or v exit, that velocity v exit is with respect to the engine. Real velocity will be v exit minus v infinity. So it will remain same. Okay, so to simplify the analysis, what we actually do is we see in the respect of engine. We make engine as stationary and then we see air coming inside and air going out. So how do we make it stationary? To make it stationary, what we do is we impart a velocity v infinity to all the three objects. We impart a velocity v infinity to this, we impart a velocity v infinity to this, we impart a velocity v infinity to this. So you see, when you impart a velocity v infinity, the air starts moving in this direction with v infinity. When you impart a velocity v infinity to the engine, it was moving in this direction with v infinity. You have imparted a velocity in this direction with v infinity. So the net resultant velocity becomes 0. And the exhaust which is coming out was moving with v minus v infinity, because this is the exact absolute velocity of the gases which are coming out. So now you see that when you impart a velocity v infinity to this, it will become v exit. Okay, so the case is same. In terms of the force, nothing changes. Okay, so this case and that case, both are same, almost same. There is absolutely nothing difference. Understood? So now to understand that, what is the force which is acting on air? Can I say m dot a plus m dot f into v minus m dot a into v infinity plus m dot f into 0. So now you see that this value will be 0. So the force that is acted on air, will be equal to mass flow rate of air plus mass flow rate of fuel multiplied by v exit minus mass flow rate of air into v infinity. This is what is the force that is actually applied on air, which is calculated from the change in linear momentum of the air. So can I say the same force would be applied by air also on the engine? Okay, so there will be a thrust component which will coming on the engine. So there will be a force applied, that is Fa. There is a force that has been applied on this engine by air, and the value of this will be m dot a, and the direction would be opposite. So the force that has been applied on air is in that direction. So there is a force applied on the engine in the forward direction. Okay, this is one component of the thrust. This is one component of the thrust. Is it clear? I hope everybody might have understood it. Okay, so now you have understood what happens purely due to the linear momentum, change in linear momentum of the body. But you see, only force on the engine is not only acting due to this. There are certain different components of force. There are other forces acting on this engine. Now, can anybody tell me what are the different forces which are acting? So to give you a glimpse, okay, let's say we have an object. Let's understand some fluid mechanics. Okay, some fluid mechanics, though Shivam sir will teach you this, but let's understand it. Let's say you have an object, a random object with a random cross section, and this object is kept in a fluid which is exerting a force or a pressure on this object P. There is a pressure which is exerted on this object, and the intensity of pressure is same everywhere, P. Okay. So can anybody tell me what is the force acting on this? What is the F resultant acting on this object? What is the resultant force acting on this object? You will say, everybody will say that the resultant force is 0. Now, what is a force due to pressure? So let's say I have a small cross-section area. I have a small area element that is, let's say, dA. This is a small area element. On this element, there is a force or there is a pressure which is acting with a magnitude P. You will see that due to this P, there will be a small force acted on this object. There will be a small force which will be acted on this object. The value of this dF will be equal to P into dA. Okay, P into dA. there will be small force acting. Okay. So in the same way, if there is an object which is kept in a fluid, you will see that everywhere there will be a pressure, and due to that pressure, everywhere there will be a force acting. So let's say there is a force acting over here, there is a force acting over here, there is a force acting over here, here, everywhere. You will see that there will be a force acting, and all these force components, it will be distributed over the full periphery. Though I am showing you only these vectors, but the force vectors will be very closely spaced. It will be a continuous force acting. I hope everybody understands this, because if you keep dividing the area into smaller and smaller, you will see that there will be many vectors of force which will be acting. Continuous. Okay. All these will be acting. So the force vectors will be looking like this. Okay. And all these vectors, when added, they will result in zero force. Why? Because force, so there is this area. If there is a force acting on this, it will move in this direction. But if there is an equal and opposite force that is acting in this direction also, then this object will remain stationary. So similarly, the resultant over here will be 0. Okay. So now let's modify this. Let's modify our problem and let's discuss slightly easier concepts. Okay. So let's say I have a square. I just want to give you a glimpse of everything, what is acting on an object. So let's say I have a square. So let's take this as the case 1. Okay. So I will write this as case 1. Case 1. Okay. So this area is, let's say, 1 meter square. This area is 0.5 meter square. This area is 1 meter square, and this is 0.5 meter square. Okay. So let's say I have an equal force which is acting on all the 4 surfaces. I have pressure as 1 bar. There is a pressure which is acting over here, which is 1 bar. There is a pressure which is acting over here, which is again 1 bar. There is a pressure which is acting over here, which is 1 bar. Okay. So all the 4 pressures are same and areas are different. Now, can anybody tell me what will be the force due to these pressures? So let's say this is 1 bar pressure and 1 meter square area. What will be the force acting on this? So 1 bar and 1 meter square. So this is 10 raised to power 5 into 1. So the total force that is acting on this surface will be equal to, F is equal to 10 raised to power 5 Newton. Okay. 10 raised to power 5 Newton will be acting in the upward direction. Similarly, on the top surface, 1 bar into 1 meter square, again there will be 10 raised to power 5 Newton acting in the downward direction. If I see over here, there will be force acting which is 5 into 10 raised to power 4 Newton. And there will be a force which will be acting over here. That will be 5 into 10 raised to power 4 Newton. So there are 4 forces acting on this surface. If I see all 4 forces, this is 10 raised to power 5. There will be a force acting 10 raised to power 5. There will be a force acting 5 into 10 raised to power 4. And there will be a force acting 5 into 10 raised to power 4. Can everybody see that this object will remain at equilibrium? This force is equal to this force. The top force is equal to bottom force. All the forces are cancelling one another. So this object will be at equilibrium. There will be sigma F will be equal to 0. I hope everybody understand this. If I have this pen over here, on this pen I am applying 5 Newton force from this side, 5 Newton from this side. Once 5 Newton are applied, you see that I am pressing this pen, but it is remaining stationary. Okay. So this remains stationary because equal and opposite forces are applied. Now let's understand a bit different case. Okay, so let's take the same case over here, but I'm going to change the values. Okay, so what I'm going to do is I'm going to change the values of some of the forces. Uh-oh. Okay, so you see we have the same figure over here, but now I'm going to change the values of the force. Okay, so to change the values of the force, you see I have to change certain parameters. So let's say I keep 1 bar same over here, but I change the value of this pressure. I change value of this and I keep the value of that same. So let's say now the pressure over here, the pressure which was 0.5, which was 1 bar over here and 1 bar over here, now I change the value of force over here. So this pressure becomes, let's say, 0.5 bar. Now, can anybody tell me what will be the force applied over here? The force applied over here is 0.5 bar into 0.5 meter square, that is 0.25 or 2.5. The force over here will be equal to 2.5 into 10 raised to power 4 Newton. So here the force is 2.5, here the force is 5. Now if you see the net resultant of all the forces on this object, there is a 5 into 10 raised to power 5 Newton acting from the top. There is a 10 raised to power 5 Newton acting from bottom. There is a force which is acting from the right, that is 5 into 10 raised to power 4. And there is a force which is acting from this side, that is 2.5 into 10 raised to power 4. Now, can anybody tell me what will be the impact of all these forces acting on the object? You see, due to these two forces balancing each out, there will be no resultant upward or downward movement. But the force which is acting from the right and force which is acting from the left, they are not equal. So now you will see that the resultant of all this will be that there will be a net resultant force acting on this object in this direction, and value of that will be 2.5 into 10 raised to power 4 Newton. This is what is your sigma F. There will be a net resultant force acting on this object. Now, can anybody tell me why this net resultant force has come up? This has come up because the pressure on the left surface and pressure on the right surface, they are not same. Pressure on the left surface and pressure on the right surface are not same. Okay, because of which there is a net resultant force acting on the object. The problem can be slightly modified as well. This problem can be slightly modified. Okay, so to understand the modified problem, let's again take the area, but now I have to modify the shape of the object. So let's say earlier the shape of the object is like this. Now I am modifying the shape of the object something like this. Okay, now I am modifying the shape of the object like this, and you see the object has been modified like this. Okay, so now the object is like this. Let's say on this object there are different pressures acting, and the pressures which are acting is from here. Let's say the pressure that is acting is 1 bar. Over here also the pressure is acting as 1 bar. over here the pressure is acting is 1 bar, okay, and on this surface there is also a pressure acting, that is 1 bar. But on this surface, now the pressure acting is, let's say, slightly higher, 1.5 bar. Okay. Let me give you certain areas as well. So this area is 1 meter square. This top curved surface, bottom curved surface are 1 meter square. And let's say this area is 0.5 meter square. Now, what will be the contribution of forces, different forces of, or the pressures which are acting over here? Okay. So to understand this, first we have to understand that how does the pressure actually corresponds on the curved surface. If there is a pressure acting on the curved surface, how do we resolve this pressure? So let's say there is a pressure of P which is acting over here. How do we resolve this pressure? So in fluid mechanics, you will understand that this pressure can be resolved in horizontal and vertical direction. So whatever are the forces which are acting on this curved surface, there will be a force which will be acting on the downward direction, and there will be a force which will be acting in the horizontal direction. So force, this is force maybe vertical, this is force horizontal. Okay, what will be the values of force vertical and force horizontal? So values of force vertical will be equal to pressure multiplied by projected area in vertical direction. Now, what do you mean by projected area in vertical direction? Projected area in vertical direction is whatever is the shadow of this area which is coming in the direction of the force. Okay? So if you see the shadow of this pressure or the shadow of this area on the horizontal axis would be like this. Okay, so this is the shadow. So this is the projected area AP, or this is the projected area which is A vertical. This blue area is the vertical area. The projection of this area on the horizontal surface. Okay, so the vertical force that is acting is pressure multiplied by area of vertical projection, and force horizontal that will be acting is force horizontal will be pressure multiplied by area projected horizontally. So AH will be this area. Okay, so this is the area AH. Okay, so the force that will be acting in the horizontal direction will be the pressure multiplied by projected area in this direction, and vertical force will be pressure multiplied by the projected area in vertical direction. Okay, so let's say I want to calculate, so these two things we have calculated, so I will move it in this, move it over here. Okay, and let's focus on our problem over here. Now you see that over here there will be different forces acting. Okay, so now tell me what will be the vertical force acting. So the vertical force that will be acting, let's say in the projected in this vertical direction and the downward direction, both the cases the projected area will remain same. Okay, so the projected area will almost be same. So let's say this is area vertical. So the force that will be acting vertically, let's say in this direction and this direction, both the direction the vertical force will be same because the pressure is same and the projected area is same. So we are not going to talk about vertical direction. Let's talk about horizontal direction. So you see horizontal direction, the force acting in this direction, force acting in the forward direction would be equal to 1 bar into 1 meter square, that is 10 raised to power 5 Newton, which is acting on the front direction, front face. Now what will be the area that is acting in, or what will be the force which is acting in this direction? So to understand the force in this direction, you have to take the area which is the curvature. Okay, So you have to take area, which is the curvature. Okay. Understand? So it will be like this. Okay. So you see the front area is 1 meter square. The total combined area is 1 meter square. Okay. On that 1 meter square, there is a pressure which is acting over here, which is 1 bar, 1 bar, 1 bar, 1 bar, 1 bar. There is a pressure which is acting over here, which is again 1 bar. Okay. So there is a same 1 bar pressure over here, 1 bar pressure over here. But there is a different pressure which is acting over here, which is 1.5 bar. Okay. So the pressure that is acting over here is 1.5. Okay. 1.5 bar. So what will be the total force contribution? Total force contribution will be due to this, and due to this. All the three. Due to this, and due to this. So the force component will be, so due to three component, the forces would be, on the top component there will be force, on the middle component there will be force, and on the bottom component there will be force. So force due to 1.5 bar, 1.5 bar multiplied by 0.5. Okay, 1.5 into 0.5 is 0.75. So 0.75 into 10 raised to power 5 Newton. Okay, 1.5 bar, 1.5 into 10 raised to power 5 into 0.5. That is 0.75 into 10 raised to power 5 Newton. Now, what will be force on this top surface? You see the top surface, the projections can be put up like this. So this becomes 0.5 meter square. Can I say this will be 0.25 meter square? And the bottom will also be 0.25. Okay. So the force on this will be 0.25 multiplied by 1 bar. So 0.25 into 10 raised to power 5 Newton. On bottom it is 0.25 into 10 raised to power 5 Newton. Does everybody understand how the forces have come up? Okay. So the forces have come up is a vertical area multiplied by pressure, vertical area multiplied by pressure, vertical area multiplied by pressure. And with this, if you see, this is 10 raised to power 5, 0.75 and 0.25 will become 1. This is 0.25. So the net resultant would be 0.25 into 10 raised to power 5 Newton force in this direction. So in this component or in this engine, the net resultant force will be on the forward direction. I hope everybody has understood this. Yes? Is it clear to everyone? Is it clear? Is it clear? I hope everybody has understood. So now, once you have understood this, now let's go back to our aircraft. Okay. So in our aircraft, what happens is, in our aircraft engine, again you see that there will be, in an aircraft engine, there will be different areas, and corresponding to those areas, there will be pressure forces. There will be pressure forces. So first, let's discuss this. And now I am going to tell you how does the pressure forces act. So momentum or force change, thrust due to different velocity components you have already seen. Now we will see what is the thrust due to pressure components. Okay. So what will be the thrust due to pressure? You see this engine, when this engine is there, this engine will have, this engine is sitting inside the atmosphere, and atmosphere had different pressures. So let's say this area, frontal area is area I. Okay, entry or air inlet, area inlet. Okay, this area which is present over here, this area is area exit. Okay. And now when the air is getting in and air is getting out, generally we see that when the air gets out, it gets out at pressure which is slightly higher than the atmospheric pressure. It exits with a pressure which is P exit. Okay. So there is a pressure P exit which is acting on the exhaust, and everywhere else there is atmospheric pressure existing. Okay, so there is an atmospheric pressure which we generally write by a term that is called as P infinity. Is it clear? So there is also pressure exerting on the front, that is P infinity. Okay, so to understand what will be the net resultant of all these forces, so can I say resolving the forces in horizontal direction? In horizontal direction, because in vertical direction we see that everything will cancel out, but in horizontal direction, in vertical direction everything will cancel out, because the projected area in vertical direction, like in this plane on the vertical, it will be same. So everywhere the pressure is same, but on the horizontal direction they will not cancel. So what is the pressure that is acting on this duct? So there will be a pressure which is acting, or there will be a force which is acting in the backward direction, that is P infinity into A inlet. So there is a force which is acting in the backward direction. Now what will be the force which will be acting from this direction? So the force that will be acting is first the center portion which is due to exit. So it will be P infinity, P exit into P exit, I have written small e, into area exit. Okay. And now this remaining portion which is the projection over here. So if there is a area like this, okay, if there is an area which is like this, okay, so this is A exit and this area is A inlet. So can I say if I remove this area exit from here, there will be a area which will be remaining, both these areas, the area will be equal to P infinity, and area will be area inlet minus area exit. So generally to see it from the front, you see that it is a circular, and in the center this is your area exit and frontal area is A inlet. So the area on which this pressure will be acting would be this area. Okay, so this area which is from the outside, you will see that there will be a pressure acted from this direction. Understanding this pink one. Okay, so the pink one area is area inlet minus area exit. Okay, so this is complete area. This is the projection. Out of that projection, area exit is what is acted by PE, and rest all the projection is acted by P infinity. So you see there will be a force that is acting out of this. So what will be the net resultant of all these forces? So you see that there are three forces acting. There is a force acting in this direction, that is P infinity into area inlet. There is a force acting in this direction, that is P exit into area exit. Plus there is another force which is acting is P infinity into area exit, area inlet minus area exit. So now if you open this bracket, you will see that there will be three terms, PE AE plus P infinity into AI minus P infinity into AE. And there will be one term which is P infinity AI over here. Okay, so the pressure, the force which is acting is P infinity AI. Over here PE, P infinity AI and P infinity AE. So you see P infinity AI and P infinity AI both will cancel out one another, and these two remaining forces will be acting in the forward direction. So the resultant force which will be acting on the resultant pressure force on the engine due to the atmospheric pressure or due to the pressure will be equal to PE minus P infinity AE, which can also be written as PE minus P infinity into area exit. So you see there is another force which is acting on the engine, that is PE minus P infinity into AE. So now if we see the total force that is acting on the engine, so let's say this is your engine, and on this engine there is a net resultant force which we actually call as thrust. So thrust which is actually existing, so this thrust which is written by term thrust T will consist of two terms. First one is m dot air plus m dot fuel multiplied by V exit minus mass flow rate of air into V infinity. This is the thrust that is coming due to the change in momentum of the air. And second is the pressure term, that is P exit minus P infinity multiplied by area exit. So this is what is actually the thrust acting on the engine. I hope everybody understood this. Yes? Is it clear? I'm sure everybody must have got this. So if you have got this, now let's do one or two questions to understand it completely. What will be the thrust generated? Okay. So to understand this question completely, let's say first question is air enters a jet engine at a velocity of 200 meter per second and exits at 280 meter per second. If the exhaust pressure is same as ambient, now what he is saying is P exhaust and P infinity, they are same. So if P exhaust and P infinity are same, that means there will be no pressure thrust. There will be no pressure thrust. Okay, and once there is no pressure thrust, that means the thrust will only be due to the air. Okay, so find the thrust generated at a mass flow rate of 100 kg per second. So there is air which is entering inside, and that air is accelerated. Okay, so we know that thrust will be equal to mass flow rate of air plus mass flow rate of fuel multiplied by V exit minus mass flow rate of air into V infinity. Now, since he has given you mass flow rate of air as 100 kg per second, but he has not given you mass flow rate of fuel. So if he has not given you, that means we will neglect it. In the real cases also, the mass flow rate is very, very low as compared to mass flow rate of air. And because of that, we generally neglect it. Okay, so 100 plus 0 multiplied by exit velocity is 280 minus 100 multiplied by inlet velocity is 200. Okay, so the thrust generated would be equal to 280 minus 200 into 100, that is 80 into 100, that is 8000 Newton. So the thrust generated would be equal to 8000 Newton. Okay, this was a very simple, because if you have understood the first two principles, if you have understood the Newton's second law, if you have understood the pressure force, then these things will be like you can solve within seconds. Understood? Very good. Now let's do one more question, which is extension of this question only, but there the pressure force is also given. Okay, so it says air enters a jet engine at a velocity of 200 meter per second and exits at 280 meter per second. If the exhaust pressure is 0.3 bar, so he has given you P exhaust is 0.3 bar, and he has given you P entry is equal to 0.28 bar. Find the thrust generated at mass flow rate of 100 kg per second if area at entry to engine is 4 square meter and area at exit is 2.2 square meter. So now we can calculate the thrust. Thrust will be equal to 100 multiplied by 280 minus 100 multiplied by 200. This is the thrust which is coming from the previous case. okay, from the acceleration of air. The second thrust will be coming from the pressure difference. So pressure difference is P infinity minus P. So P infinity is P exit is 0.3 minus 0.28 into 10 raised to power 5. This is pressure difference, P exit minus P infinity multiplied by area of exit. So area of exit is 2.2 square meter. So 2.2. Okay. So you see this will come out to be 8,000 Newton plus this will be 0.02. 0.02 into 10 raised to power 5 into 2.2. So this will be 2 into 10 raised to power 3, that is 2000 and 4.4 thousand. So this will be 8,000 Newton plus 4,400 Newton. So the total force will be equal to 12.4 kilonewton. So you see what a small difference, what a small force, small pressure difference, 0.3 and 0.28. It is very small pressure difference. This pressure difference can mean a lot to the force. Understood? So I hope all of you have understood the concept of generation of thrust, because in the next lecture, now we are going to discuss the propulsive efficiency. And propulsive efficiency would use the same equation that we have derived over here. The performance of engine that we see would be extension of the thrust which is generated over here. I am sure you might have enjoyed this lecture. Do let me know how did you find this lecture, because I know this type of content you might be studying for the first time. Okay, so thank you so much, and see you all in next lecture. Thank you.